Hello, this is a new series of videos. In this series, I will collect challenging problems, such that Wolfram Alpha and Wolfram Mathematica couldn't solve. And today, let's look at this definite integral problem. Before we move on, don't forget to subscribe to my channel, turn on the notification, and give a like. Let's get started. Here is the output from the Wolfram. For the left panel, this is from the Wolfram Mathematica. And you can see here, after we type in this integral, the Mathematica couldn't solve it analytically. Even though we set a equals to some integer, for example here we set a equals to 2, Mathematica still cannot solve it analytically. For the right panel, this is the output from the Wolfram Alpha. And you can see here, it says the standard computation time exceeded. So Wolfram Alpha cannot solve it either. Since Wolfram failed to solve it, we have to solve it by hand. And here we require a is greater than 1. Otherwise, the term inside the square root and inside the log function will be negative. So the first step is to use the change of base formula to write log a2 equals to log 2 over log a. And then we put this numerator in front of this long fraction. And next, we do the substitution. We let u equals to the square root term. And then we square them on the both sides, so we got u squared. And next, we plug them back into this integral, so we got here. And then we need to deal with this blue term, the x term, and this green term, the dx term. So we start from this equation inside this purple box. And we can write this equation into this form. And next, we take the natural log on both sides. And then we divide log a on both sides, so we can solve for x. And next, we take the derivative respect to u, so we can get dx. And note for the numerator, the 2u is coming from the chain rule. Now we are ready to plug them back into this integral to replace the x and the dx term. After replace them, we got here. The u cancel out, and we got here. The first term inside the parentheses goes to here. And we can take the power index in front of the log function. In this way, the number 2 cancel out. And I copy them here. And next, we take the log a out of this integral, so it becomes log a squared. And for these two green terms, we can write the subtraction into the division inside the log function. And note for this equation inside this red box, we call it red box equation, and we will use it later. And next, we do another substitution. We let u equals to 1 over t. And then we do the derivative respect to t, so we got du, which is equals to minus 1 over t squared dt. So we plug in u equals to 1 over t into this integral, and then we plug in du. So this integral is converted here. And note for this integral limit, because we did the reciprocal substitution, we let u equals to 1 over t, so the upper and lower integral limit are flipped. And next, we will simplify this equation in the next slide. I copy it here. So first, we use this negative sign in front of this 1 over t squared term to flip this lower and upper limit back. And we got here. And then for these two terms in the denominator, we can multiply them together and simplify them. So we got here. And next, we will deal with this term inside this green box. So we multiply t squared on both numerator and the denominator inside this log function. So this term is simplified to here. And for this term inside this blue box, it equals to minus log t. And I copy them here. After plugging in those simplified results, we got here. And note for this negative sign here. Because we know the property for the log function, the minus log x over y equals to log y over x. So we can use this negative sign to flip the numerator and the denominator for this log function inside this red circle. So after flip them, we got here. Because this is a definite integral, so we are free to choose the integration variable. So we choose u as the integration variable. And recall for this red box equation, as I mentioned before, we will use it here. So we add these two equations together. I copy them here. So after we added them together, we got here. And then we use the property for the log function. We can write the addition into the product inside the log function. So we got here. And these two terms cancel out. And number 2 also cancel out. So this integral is reduced here. And note for this green term, it equals to 2 times log u. I copy them here. So after replace this green term by 2 times log u, we got here. And the log u cancel out. The number 2 also cancel out. So it reduced to a very simple integral. Then we just integrated and we got arctangent u. After plugging numbers, we got this final answer. And don't forget to subscribe my channel and give a like. That's all for today, and thank you for watching.